Is speed of light equal to electrons' inertia? We will study this hypothesis in this video. Let us take two electrons, a free electron and one bounded to an atom, represented by the white box. When the bounded electron moves, assuming it is a source, the free electrons feels an oscillating repulsive force. Now if we take both electron bounded to an atom, assuming one is a source and the other a sensor, we have a repulsive force that pushes the sensor electron. We can interpret that as the source emitting a photon and the sensor absorbing that photon. If we take 3 electron, one can see that the force angle changes depending on the distance of the electron to the source. And if the 3 electrons are bounded, we can define the speed of light as the distance of the electron to the source divided by the delay of the electron's motion. This new definition of the speed of light means that speed of light is infinite. And when we measure speed of light, we actually measure the inertia of electrons. If we take a different organization with the source in the center and the sensors to the sides, then we created intricate photons. Let us apply this new light-matter framework to a well-known scientific experiment, the single-slit experiment. In this experiment, a coherent light source shines onto a tiny slit, and one can observe an interference pattern on the screen behind. Now if we use our bounded electron framework, we can have a new scheme like that. Each point is an electron. If we put the light source on, it shines on the whole slit, and a little bit goes through the slit onto the screen. But the moving electrons of the slit become secondary coherent sources, and they affect the electrons of the screen. Those two secondary sources are the sources that create the interference pattern on the screen. Zooming on the top part of the slit, we can see that the optical excitation dampens in the thickness of the slit.